In this lesson, we want to talk about the Pythagorean and quotient identities. We'll look at the ranges of trigonometric function values, and also we'll see some examples where we're finding missing function values. So before we jump into the lesson, for reference sake, let's go through the 6 trigonometric functions again. I want you guys to remember the way we've defined this. We've said that r is equal to the square root of x squared plus y squared. Okay, so remember that. So I can also say, if I square both sides, that r squared is equal to x squared plus y squared. So we'll be using this in a moment. So I want you to recall that we defined sine of theta as y over r. We defined cosecant of theta as r over y, where y is not allowed to be 0. Now, you'll notice that, again, sine of theta and cosecant of theta, those guys are reciprocals. Remember your reciprocal identities that we talked about in the last lesson. Then we have our cosine of theta, which is x over r. Our secant of theta, which is r over x. X is not 0. Again, these two guys are reciprocals. Then you have your tangent of theta, which is y over x. X is not equal to 0. And your cotangent of theta, which is x over y. Y is not equal to 0. Again, these guys are reciprocals. Now, our first topic of today's lesson is going to be the Pythagorean identities. So you'll usually see these in your book in this exact manner. So sine squared theta plus cosine squared theta equals 1. Your tangent squared theta plus 1 is equal to your secant squared theta. And then 1 plus cotangent squared theta is equal to cosecant squared theta. So how do we get the first one? So we have our sine squared theta plus our cosine squared theta is equal to 1. We'll see other ways to do this when we get to the unit circle. For right now, we're just going to divide everything by r squared, okay, by r squared. And we know that r squared divided by r squared would be 1. So when we look at this guy, we can say this is now going to be x squared over r squared plus y squared over r squared is equal to 1. Okay, so now using the rules of exponents, remember, I have a 2 here and a 2 here as an exponent, and a 2 here and a 2 here as an exponent, so I can pull that outside of a set of parentheses, right, using my power rules. So I can say this is x over r, okay, this amount here would be squared, then plus you have y over r, this guy here would be squared, this equals 1. Well, by definition, we just saw that x over r is cosine of theta, okay, and then y over r is sine of theta. If we go back up, again, sine of theta is y over r, cosine of theta is x over r. So I could replace this guy right here by saying it's cosine of theta being squared. And I could replace this guy, let me just kind of move this down. I could say this is sine of theta being squared, and this equals 1, okay? So I could apply my exponents and use the commutative property to get into this form here. I can write this as cosine squared theta, okay? And I could write this as sine squared theta, okay? And then I could just switch the order because, again, this is just addition. So when you add two things together, the order doesn't matter. So that's how we get to this form right here. So let's look at the other ones. So we have tangent squared theta plus 1 is equal to secant squared theta. So to get this, let me just erase everything. You're just going to divide everything by x squared now. Okay, quite easy. So divide this by x squared, this by x squared, this by x squared. And we know that this guy is going to be 1. All right, so we know we would have 1 plus, you'd have your y, and I'm just going to write this as y over x, this guy squared, because we know we do that step anyway, is equal to r over x, this guy squared. What is y over x? We know that this is the tangent of theta. So we go back up, again, y over x is the tangent of theta. So you can replace that. You can say this is 1 plus the tangent of theta, this guy squared, is equal to, what is r over x? Well, r over x is the secant of theta. Okay, so we go back and we say this is the secant of theta. Let me make that a little bit better. The secant of theta, this guy is being squared. And again, you can apply your exponents and just say this is the tangent squared theta, okay? And this is the secant squared theta, okay? And then the way we had it was tangent squared theta plus 1 is equal to secant squared theta. So all we'd have to do is just rearrange this and say, okay, I have the tangent squared theta plus 1 equals secant squared theta. Let's look at the last one, which is this guy right here. So 1 plus cotangent squared theta equals cosecant squared theta. And to get this one, I'm just going to divide everything by y squared. And again, it's going to be the same trick overall. So now this guy is going to be 1. So I would write this as x over y. This guy would be squared. Plus this would be 1. This equals, you'd have r over y. This guy is squared. okay? So x over y, we know that's cotangent, right? So cotangent of theta. X over y is the cotangent of theta. So let's go ahead and say we have cotangent of theta. And I'm just going to put cotangent squared of theta. We know it would end up being that anyway. So then plus 1 equals, what's r over y? So r over y is cosecant of theta, okay? So I'm going to say this is cosecant squared of theta, okay? And again, if I go back, all I have to do is switch the order of these two. So I'll just write this as 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, so that's where those three guys come from. Not very difficult to derive overall, but something you might see in your book and get a bit confused about. All right, so now let's move on and look at the quotient identities. These are a lot easier to understand. You have sine of theta over cosine of theta gives you the tangent of theta. Remember, sine of theta is y over r, and cosine of theta, if I divide it by that, it's x over r. Well, what do we do here? This is y over r times the reciprocal of this, which is r over x, okay? So the r's cancel and you get y over x, which by definition is the tangent of theta. So the other one is the cosine of theta over the sine of theta gives you the cotangent of theta. Well, before you even do this, remember, the tangent of theta, okay, which is y over x, and the cotangent of theta, which is x over y, those guys are reciprocals. Well, look at what I did here. I just took the reciprocal of just what I was working with. I had sine of theta over cosine of theta. Now I've flipped that. I have cosine of theta over sine of theta. So, of course, I'm going to get the reciprocal of what I got before, which is the cotangent of theta, okay? So now all I would have is x over r divided by y over r. This is x over r times the reciprocal of this, which is r over y, okay? So these cancel and you get x over y, which again is the cotangent of theta. All right, so one last thing before we start doing these problems. In a lot of cases, you need to know the ranges of the 6 trigonometric functions because you'll go to solve a problem and you might get something that's not possible, but you think that it is possible, and we'll see that on the first example. I'll show you exactly what I mean. So when you look at your trig functions, you have this range. When you think about sine of theta and cosine of theta, the value needs to be from -1 to 1, including -1 and 1, but in that range, okay? When you work with tangent of theta and cotangent of theta, it can be any real number, okay? It can be any real number. When you work with the secant of theta or the cosecant of theta, well then you could really say this is just that the absolute value has to be 1 or larger, right? Because you can have from -infinity up to and including -1, and then also from 1 out to positive infinity, okay? So basically the absolute value needs to be 1 or larger, okay? It can't be less than that. All right, so let's look at our first example here. We're going to use the identities to find cosine of theta and sine of theta, given the fact that the tangent of theta is 7/3 and the sine of theta is less than 0, meaning it's negative. So first and foremost, think about the quadrant you're going to be in. Remember that all students take calculus. So we have our 4 quadrants, 1, 2, 3, I'll put 4 marks there, should be 3. So 3 and then 4, okay? So all students take calculus. All right. We know that T stands for the tangent of theta and also the cotangent of theta, the reciprocal. So it's positive in quadrants 3 and also in quadrant 1 because everything's positive in quadrant 1. Sine of theta is negative, okay, in quadrants 3 and 4 because the S stands for the sine of theta. So we know that we're in quadrant 3 because it meets both criteria, right? It's going to be positive for the tangent of theta and negative for the sine of theta. So we will be in quadrant 3, okay? So keep that in mind when you get stuff to know whether it's positive or negative. Now, the other thing is, and this is a very common mistake, remember we just said that the tangent of theta is equal to the sine of theta over the cosine of theta. So what students do is they say, okay, well, sine is negative, and I know that tangent is positive, so what they'll do is say, okay, well, this is going to be -7 over -3, okay, over -3, and they think they're done with the problem. This is a very common mistake. Why doesn't it work out this way? Remember, the range for sine of theta and cosine of theta is from -1 to 1, including those two numbers. So this is not possible. You can't have a -7 and you can't have a -3. So throw that out, okay? So what we're going to do is we're going to take our Pythagorean identity that includes the tangent of theta, and we're just going to plug into that. So we have the tangent squared of theta, okay, plus 1 equals the secant squared of theta. Okay, so you might be saying, why would we plug into that? We're trying to find cosine of theta and sine of theta. Well, remember, the secant of theta is the reciprocal of the cosine of theta, okay? So if we find the secant of theta, we can flip it, we'll have cosine of theta, okay? And once we've done that, we know that our other identity involves sine of theta and cosine of theta. We can plug into that and figure out our sine of theta. So let's just go ahead and knock this out. We're given that the tangent of theta is 7/3. So you would want to plug in here, okay? But remember, this guy's being squared. So when you plug in here, make sure that you square this guy. It's very important, okay? So we come down here. Once you've plugged in, the rest of this is really, really easy. You're just doing some basic algebra. 7 squared is 49. 3 squared is 9. Then you're going to add 1 to that. So get a common denominator. Let's just say this is 9 over 9, okay? This is equal to secant squared of theta, okay? So let's go down a little bit more. I'm going to flip this around and put this guy on the left. So secant squared of theta is equal to 49 plus 9 is going to give me 58, and this is over 9. Now, to get this in the form of secant of theta, okay, what I want to do, since this is being squared, I want to take the square root of each side. Remember, on this side, I want to go plus or minus, okay, the square root of 58 over 9. I'm only going to need one of these. Remember, I'm in quadrant 3. That's what we did that to begin with. I'm in quadrant 3. In quadrant 3, the secant of theta is going to be negative, so throw out the positive one. You just need the negative, okay? That's all you want. So let's scroll down a little bit, and we'll say the secant of theta, okay, is going to be equal to the negative of, this would simplify because the square root of 9 is 3, so I'll say the square root of 58 over 3, okay? So we're not looking for the secant of theta. Of course, we want the cosine of theta, and I know this is a bit tedious, but the cosine of theta is found by flipping this guy. So this is equal to the negative of 3 over the square root of 58. Now, when you have an answer with the square root in the denominator, you typically want to rationalize the denominator. So let's multiply this by the square root of 58 over the square root of 58. And that would give me an answer of the negative of 3 times the square root of 58 over 58. Okay, so that's my cosine of theta. I also wanted to find sine of theta. Okay, so sine of theta, what is that equal to? Remember, sine squared theta plus cosine squared theta is equal to 1. Well, I can plug in for the cosine squared theta. I'm just going to plug in the non-rationalized version here. So I'm going to put negative 3 over square root of 58. Okay, you don't need the rationalized one because this is not the final answer. Let's copy this because we're going to run out of room. Go to a fresh sheet here. And let me erase this. We don't need that. And scroll down a little bit more. So if I square this, let's just go ahead and put sine squared theta plus. If I square this, I'm going to get positive, of course, 9 over 58. And this equals 1. Okay, so all I got to do is subtract this away from each side of the equation. So I'll have sine squared theta is equal to 1 minus 9 over 58. And of course, we just get a common denominator going. So I'm going to say this is 58 over 58. And 58 minus 9 would be 49. So this is 49 over 58. So this is 49 over 58. Okay, so to get sine of theta, remember you're taking the square root of each side. So do you want the positive or the negative square root? Remember, sine of theta is going to be negative in quadrants 3 and 4. We're in quadrant 3, so it's going to be negative. So I want the negative square root of 49 over 58. Okay, let me make that reach all the way. And of course, this is equal to the negative of, you have the square root of 49 is 7, so we'd have 7 up here, over, you'd have the square root of 58. And to make this a little bit cleaner, because again, we want to rationalize the denominator, sine of theta is going to be equal to, you have the negative of 7 times the square root of 58 over 58, right? Because I'm going to multiply this by the square root of 58 over the square root of 58, and I'll be done. So sine of theta is equal to negative of 7 times the square root of 58 over 58. All right, so let's take a look at another example. We want to find sine of theta and tangent of theta, given the fact that the secant of theta is negative 2 and the cotangent of theta is greater than 0, or you could say positive. So the first thing is, what quadrant are we going to be in? Well, where's the secant of theta negative? It's going to be negative in quadrants 2 and also 3. Okay, and then where is cotangent of theta? Where is that positive? It's positive in quadrants 1 and 3. Okay, so 3 matches both conditions there. So we'll say this is in quadrant 3. Okay, so this is going to be in quadrant 3. So when we look at this, we know that our sine of theta will be negative and our tangent of theta will be positive. Okay, so keep that in mind when you're solving this problem. So the first thing is we're given the secant of theta, it's negative 2. So let's plug in to this guy. We have the tangent squared theta plus 1 is equal to the secant squared theta. So I'm just going to plug in for this. Remember, it's squared, so it would be negative 2 squared, negative 2, both the negative and the 2 being squared. If I did that, that would be positive 4. So let's just erase this and put 4 in here. Okay. I'm going to subtract 1 away from each side of the equation, so this is gone, and this would be a 3. So what you have here is tangent squared theta is equal to 3. If I want to find out what tangent of theta is, I'm going to take the square root of each side. Remember, we already said this guy is going to be positive, so I don't need the plus or minus. I just want the principal square root here. So it's just the principal square root of 3. Okay, so that's my tangent of theta. So now that we know what the tangent of theta is, how can we find the sine of theta? Well, one thing we can do, we can flip this guy. Since the tangent of theta and the cotangent of theta, those guys are reciprocals, I can say my cotangent of theta is just flipping this guy. Remember, if it's not displayed as a fraction, just write it over 1 and then flip it. So you can say this is 1 over the square root of 3. We're not going to rationalize this here because this is not going to be our final answer. So what I'm going to do now is I'm going to plug this in. I'm going to plug this in for our Pythagorean identity where it says 1 plus our cotangent squared theta is equal to cosecant squared theta. Remember, the cosecant of theta and the sine of theta, those guys are reciprocals. So I can plug in here, find out what this is, flip it, okay, and I'll have sine of theta. So let's go through and plug in. We'll have 1 plus, I'm going to plug this guy in here, 1 over square root of 3. And this guy's going to be squared, and this equals my cosecant squared theta, okay? Let's get some room going. And so now if I square this, I'm going to get what? I'm going to get 1 squared is 1. Square root of 3 squared is 3. So this is just 1/3. This is just 1/3. To add this to 1, I'm going to get a common denominator and say this is 3 over 3. So this is basically going to give me 4/3. So 4/3 is equal to, and let me write this in another way. So cosecant squared theta is equal to 4/3. Okay, so to solve for this guy, remember the cosecant in quadrant 3 is going to be negative. So I'm going to take the square root of this side. I'll say the cosecant of theta is equal to, over here I want the negative square root of 4/3. So the cosecant of theta is going to be the negative of, the square root of 4 is 2, and then over the square root of 3. So now let's cut this. We'll go to a fresh sheet, and we'll just paste this in right here. So remember, if I want the sine of theta, I just flip this guy. Okay, so if I flip this guy, I'm going to have the negative of the square root of 3 over 2, and that's my answer. All right, let's look at one that involves the quotient identities. So we have find sine of theta and tangent of theta, given the fact that our cosine of theta is equal to negative 2 times the square root of 2 over 3, and sine of theta is negative. So cosine of theta is negative here. Where is cosine of theta negative? Well, it's negative in quadrants 2 and 3. Where is sine of theta negative? It's negative in quadrants 3 and 4. So again, we have a situation where we're in quadrant 3. Okay, and it doesn't always work out this way. We had 3 problems today where they're all in quadrant 3, but it's going to vary based on the problem you're given. So we know we're in quadrant 3. From here, we're going to say that we know our sine would be negative, it's given to us, and we know our tangent is going to be positive because we're in quadrant 3. Okay, so how do we find our sine of theta? Well, we can use our Pythagorean identity, the one that says cosine squared theta plus sine squared theta equals 1. And I know this is normally reversed, but I'm writing it this way to give myself some room because I want to plug in here. So I'm going to plug in for cosine theta, okay? So I'm going to say this is negative 2 times the square root of 2 over 3. Remember, this guy is squared. It's so important that you don't forget to square things, okay? So if I square this guy, the negative becomes positive, so you can forget about that. 2 squared is 4. The square root of 2 squared is 2, okay? 4 times 2 would give me 8. And then down there you have 3, which is squared, which is 9. So I have 8/9 plus sine squared theta equals 1. Okay, let me erase this. We're just going to kind of stick around here because I'm going to need some of that information, so I'm going to be going back up. So let me just kind of drag this up a little bit so that we stay right here. Okay, so what I'm going to do now is I'm going to subtract 8/9 away from each side. So I'm just going to erase it from over here. I'm going to write this as 9/9. So I have a common denominator, and then we're going to subtract away that 8/9, okay? 9/9 minus 8/9 is 1/9. Okay, so 1/9. Remember, sine of theta is negative. So if I take the square root over here, I want sine of theta is equal to the negative square root of 1/9. Now, the square root of 1/9 is the square root of 1, which is 1, over the square root of 9, which is 3. So it's 1/3. All right, so this is negative 1/3. Negative 1/3. All right, so let me erase this real quick. I'm just going to drag this over here. And I want to find tangent of theta now, given the fact that I know what cosine of theta is and I know what sine of theta is. Remember, the tangent of theta is defined as the sine of theta divided by the cosine of theta, okay? So what I can do, it's going to be hard to fit this in this limited room I have, but I would have that the tangent of theta, let me just write that over here. So the tangent of theta is equal to, the sine of theta is negative, the negative of 1/3 divided by the cosine of theta, which is the negative of 2 times square root of 2 over 3. So let me just copy this, and we're going to go to another sheet. We'll paste this in here real quick. So this is equal to what? It's equal to the negative of 1/3 times, flip this guy, the negative of 3 over 2 times square root of 2. Of course, the negatives are going to cancel. Forget about those. The 3's are going to cancel. So what I'm left with here is 1 over 2 times square root of 2. Let's rationalize. We're going to multiply by square root of 2 over square root of 2. And this gives us the square root of 2 over, square root of 2 times square root of 2 is 2, 2 times 2 is 4. So square root of 2 over 4 would be your tangent of theta.